Have you ever wondered what happens when you take absolutely everything away? Imagine, if you will, a simple box resting in the quiet dark. Now, imagine taking every single thing out of that box. You carefully remove the everyday objects, the floating specks of dust, the invisible currents of air. You use a magnificent, theoretical pump to extract every solitary atom, every wandering molecule, every microscopic trace of physical matter. You build walls so impossibly thick and perfectly reflective that no light, no stray warmth, no cosmic radiation of any kind can ever penetrate its serene interior. You have isolated this space completely from the endless noise and chaos of the outside universe. What is left inside your box? Our everyday intuition, shaped by a lifetime of walking on solid ground and breathing dense air, tells us that the box must now be completely empty. It contains nothing at all, just a profound, silent void. But the universe, in its infinite elegance and deeply guarded mystery, does not seem to tolerate true nothingness. The cosmos, it turns out, is infinitely more creative than our common sense could ever suggest. Let us embark together on a quiet journey into the very fabric of reality itself. A journey into the microscopic abyss, where the familiar rules of our visible world gently fade away, replaced by the strange, beautiful, and restless dance of the quantum realm. As we prepare to dive into this ocean of the infinitely small, to explore what modern science reveals about the vacuum of space, I want to take a brief, quiet moment to welcome you. You are watching Walter, the Explorer. This is our shared, peaceful corner of the cosmos where we seek to understand the grandest and most quiet mysteries of our universe together. I recently looked at our community and realized that roughly 73% of the wonderful people who watch these cosmic journeys have not yet subscribed to the channel. If you find comfort, peace, and wonder in these gentle explorations of science, please consider subscribing. It truly helps us bring more of these contemplative stories to you, and it lets us know that you want to continue this quiet voyage of discovery by our side. Now, let us gently return to our perfectly isolated, empty box and the profound, invisible secrets it hides in the dark. For thousands of years, the concept of nothingness has troubled the greatest minds of humanity. Ancient philosophers looked up at the night sky and wondered if the vast distances between the cold, distant stars were filled with an invisible substance, an ethereal fluid that carried the light of the heavens, or if it was simply a terrifying, absolute void. Some believed that nature abhorred a vacuum, that the universe would rush to fill any truly empty space the moment it was created. They could not fathom a reality where space existed without something occupying it. As centuries gently passed, and human understanding of the natural world grew more sophisticated, our vision of the void evolved. By the time the great classical physicists began to write the mathematical laws of the universe, they viewed space as a grand, passive stage. It was a silent, rigid theater where the dramatic play of stars, planets, and moons unfolded. In this classical view, if you removed all the actors, if you took away all the massive bodies and brilliant light, the stage would simply remain empty, dark, and perfectly still. It was an intuitive, comfortable way to understand the vastness of the cosmos. Space was merely the container, and if you emptied the container, you were left with pure, undisturbed nothingness. But as the 20th century dawned, the comforting certainty of classical physics began to fracture. Scientists developed new instruments, peering deeper into the nature of light and the hidden structure of atoms. What they found there did not make sense according to the old rules. The universe, when examined at the most incredibly tiny scales, behaved in ways that defied human logic and challenged everything we thought we knew about certainty, solidity, and stillness. This was the birth of quantum mechanics, a scientific revolution that would forever change our relationship with reality, and, ultimately, our understanding of the empty vacuum. To understand the quantum vacuum, we must first gently embrace one of the most profound and unsettling principles ever discovered in modern physics. It is a concept that tells us there is a fundamental limit to what we can know about the universe, not because our instruments are flawed, but because the universe itself refuses to be perfectly pinned down. This is the uncertainty principle, formulated in the late 1920s. In our everyday world, you can park a car and know exactly where it is and exactly how fast it is moving, which is zero. You can have absolute stillness and absolute certainty. But in the quantum realm, the realm of the impossibly small, nature forbids this kind of absolute precision. The more precisely you try to measure the exact position of a tiny particle, the less you can know about its momentum or where it is going. And, conversely, the more you know about its motion, the less you know about exactly where it is. It is as if the universe insists on keeping a certain amount of mystery, a foundational fuzziness that cannot be erased. You cannot have a quantum object sitting perfectly still in a perfectly defined location. That would mean zero uncertainty in position and zero uncertainty in momentum, which the laws of quantum physics strictly forbid. Now, let us bring this profound realization back to our perfectly empty box, our isolated vacuum. We stripped away all the atoms, all the light, all the energy we could possibly measure. We tried to create a state of perfect zero. Zero matter, zero energy, zero movement. But the uncertainty principle whispers a fundamental truth. You cannot have a perfect zero. If the vacuum of space had exactly zero energy, and that energy never changed, we would have absolute certainty about its state. We would know its exact energy, which is zero, and its exact rate of change, which is also zero. Quantum mechanics simply does not allow this. Therefore, even when you remove absolutely everything, the empty space that remains cannot be truly, perfectly empty. It cannot sit in a state of absolute, dead stillness. Instead, the vacuum must have a baseline level of energy, a restless, irreducible minimum of activity that can never be quieted. Physicists call this the zero-point energy. It is the lowest possible energy state that a physical system can possess, and, crucially, it is not zero. The empty space inside our box, the vast, dark stretches between the galaxies, the microscopic gaps between the atoms in your very own body, all of it is humming with this quiet, invisible energy. It is a concept that challenges our deepest intuitions about what it means for a space to be empty. How can nothing have energy? How can a void be active? Think about the quietest place you have ever been. Perhaps it was a snowy forest at midnight, where the thick blanket of white absorbed every stray sound, leaving only the gentle rhythm of your own breathing. Perhaps it was a desert, stretching endlessly under a canopy of ancient, brilliant stars, where the silence felt almost heavy against your skin. In those moments of profound earthly quiet, we feel a sense of absolute stillness. We feel as though the world has stopped, resting in a state of perfect peace. But this feeling, as beautiful and restorative as it is for our restless human minds, is an illusion. It is a macroscopic trick played by a universe that, at its very core, never sleeps and never stops moving. The silence of the snowy forest and the stillness of the midnight desert are built upon a foundation of microscopic chaos, an endless, bubbling reality that operates far below the threshold of our limited senses. To truly comprehend the quantum vacuum is to accept that stillness is a profound illusion. It requires a gentle shift in our perspective, a humbling realization that the universe is far more complex, far more dynamic, and far more wondrous than our daily experiences would lead us to believe. It invites us to look at the empty air around us, or the vast, dark spaces between the twinkling stars, and recognize that they are not empty voids, but fertile fields of cosmic potential. This brings us to the most beautiful and counterintuitive realization of all. The quantum vacuum is not an empty stage. It is not a passive theater waiting for stars and planets to perform. The stage itself is alive. The fabric of the cosmos is a restless, churning ocean of potential. When we look out into the deep, dark night sky, past the familiar constellations and the glowing dust of our home galaxy, we are not looking into a dead void. We are looking into a vibrant, unseen medium that holds the fundamental secrets of existence. It is a medium that connects us to the very beginning of time and to the farthest edges of the universe. In the chapters to come, we will slowly unravel the nature of this restless ocean. We will discover what exactly is fluctuating in the dark, how particles of matter can spontaneously appear from the void, and what this means for our understanding of reality, existence, and our own fleeting presence in this majestic, strange cosmos. We will explore the delicate balance of forces that allows us to exist at all, floating in a universe where even nothingness is profoundly something. The journey ahead will challenge your intuition, but it will also offer a deep, contemplative peace. For in understanding the restlessness of the void, we come to understand the very foundation of our own existence. Let us close our eyes for a moment and picture a vast, calm ocean stretching out toward an endless horizon. From the shore, the surface of the water appears perfectly flat, a mirror reflecting the pale light of an ancient sky. This is how we traditionally imagine the empty spaces of our universe. We look out into the deep night, past the glowing atmospheres of our neighboring planets, past the swirling dust lanes of the Milky Way, and we see an ocean of darkness that seems entirely tranquil. Our human senses, adapted to the macroscopic world of trees and slow-moving rivers, interpret this darkness as an absolute silence, a realm of frozen nothingness where nothing exists. But as we slowly sink beneath the surface of this cosmic ocean, leaving our everyday intuitions behind on the distant shore, we begin to discover a reality that is breathtakingly different. The quiet void is an illusion, a trick of scale played upon our minds. To truly grasp the nature of the quantum vacuum, we must gently unlearn the idea of empty space as a mere container. Instead, we must embrace the profound concept of fields. In the quiet language of modern physics, a field is an invisible presence that permeates every single corner of the infinite cosmos. You are already intimately familiar with this concept, even if you do not realize it. Think of a simple magnet resting gently on a wooden table. When you hold another magnet close to it, you can feel an invisible force pushing them apart, or pulling them together long before they actually touch. That soft, invisible tug in the space between your hands is a magnetic field. It is a property of space itself, modified by the presence of the magnet. Now, imagine stretching that concept across the entire universe, filling every void and every gap. According to quantum field theory, one of the most rigorously tested mathematical frameworks in the history of human thought, the cosmos is entirely filled with these invisible fields. There is an electron field, a quark field, a photon field, and many others, all gently overlapping, extending infinitely into the vast darkness. Before we dive deeper into the beautiful, restless nature of these cosmic fields, I want to take a brief, quiet moment to speak with you directly. You are watching Walter, the explorer. This is our shared, peaceful corner of the cosmos where we seek to understand the grandest and most quiet mysteries of our universe together. I recently looked at our community and realized that roughly 73% of the wonderful people who watch these cosmic journeys have not yet subscribed to the channel. If you find comfort, peace, and wonder in these gentle explorations of science, please consider subscribing. It truly helps us bring more of these contemplative stories to you, and it lets us know that you want to continue this quiet voyage of discovery by our side. Now, let us gently return to our invisible fields, rippling softly in the dark. When we talk about a particle, like an electron orbiting the nucleus of an atom in your fingertip, we are not talking about a tiny, hard sphere floating in an empty void. In the profound view of quantum physics, an electron is simply a localized vibration, a tiny, energetic ripple in the universal electron field. It is a momentary excitation, much like a small wave cresting on the surface of our cosmic ocean. If you impart enough energy to the field, a wave appears, and we call that wave a particle. But what happens when you remove all the energy? What happens when the wave subsides, the vibration stops, and the field is allowed to rest in its lowest possible energy state? This, my fellow explorers, is what physicists call the vacuum state. The quantum vacuum is not the absence of fields. It is simply the state where all these ubiquitous fields are as quiet, as still, and as empty as the strict laws of physics will allow. But here is where the profound mystery of the universe gently asserts itself once more. As we learned from the uncertainty principle, the laws of quantum physics strictly forbid absolute stillness. You cannot have a field that is perfectly, entirely flat. You cannot have an ocean without the slightest, most microscopic tremor. The universe simply refuses to be completely silent. Therefore, even in its lowest energy state, even when no permanent particles exist, the fields that permeate the cosmos are constantly fluctuating. They are shivering with a fundamental, inescapable zero-point energy. This trembling of the quantum vacuum is a reality that has been confirmed time and time again by brilliant minds working with precise instruments at places like the European Organization for Nuclear Research, or CERN, and by incredibly delicate observations made by space telescopes launched by NASA and the European Space Agency. This inherent restlessness of the fields gives rise to a phenomenon so strange and so beautiful that it sounds like magic, yet it is absolute scientific truth. Because the fields are constantly vibrating with this zero-point energy, they occasionally borrow a tiny, infinitesimal amount of energy from the vacuum itself. For a fraction of a second, so microscopically small that no human mind can truly comprehend it, this borrowed energy spikes high enough to create a pair of particles, a normal particle and its exact opposite, an antiparticle. For example, a virtual electron and a virtual positron will suddenly pop into existence out of the seemingly empty dark. They exist for a fleeting, beautiful moment, born from the intrinsic vibration of space. But the universe is a strict, unyielding accountant. The energy was only borrowed, and it must be returned almost immediately. Driven by their opposite natures, the two virtual particles crash back into one another, annihilating in a silent, invisible flash, returning their borrowed energy to the vacuum from which they emerged. This astonishing process is happening right now, everywhere, all the time. It is happening in the dark, frozen gaps between the most ancient, distant galaxies. It is happening in the vast, quiet expanses of our own solar system. And, perhaps most wondrous of all, it is happening inside the atoms that make up your very own body. The space inside you is boiling with this invisible, microscopic creation and destruction. The vacuum is a frothing, bubbling sea of virtual particles, constantly appearing and disappearing in an infinite, silent dance. The great astronomer Carl Sagan once spoke of the cosmos as something we are a deeply connected part of, noting that we are a way for the universe to know itself. When we look inward, down to the deepest, most fundamental levels of reality, we see that the fabric of our existence is woven from this restless energy. We are not solid beings standing in an empty space. We are complex patterns of stable energy floating in a vibrant ocean of quantum potential. Why does this matter to us? Floating here on our small, rocky planet, wrapped in our fragile atmosphere. It matters because this bubbling vacuum is not just a mathematical curiosity. It has real, measurable effects on the physical world we inhabit. The virtual particles popping in and out of existence in the quantum vacuum exert a tiny but very real physical influence on the matter we can actually see. They slightly alter the energy levels of electrons in atoms, producing a minute shift that scientists can measure with astonishing precision in laboratories around the world. They even create a subtle, attractive force between perfectly smooth metal plates placed very close together in a perfect vacuum, a mesmerizing phenomenon known as the Casimir effect. The vacuum, with all its hidden, frantic activity, literally pushes and pulls on the visible universe. It is the invisible, trembling foundation upon which all of reality is built. As we gently float in this contemplative space, absorbing the vastness of the microscopic world, we can begin to find a strange, comforting peace in the restlessness of the vacuum. We often fear emptiness. We fear the dark, silent stretches of the cosmos because they seem lonely and devoid of meaning. But the quantum vacuum tells us a completely different, profoundly comforting story. It tells us that there is no true emptiness. There is no absolute dead void. Even in the deepest, most profound isolation, the universe is alive. The cosmos is eternally humming with potential, forever giving birth to momentary sparks of existence. It is a gentle reminder that we are never truly separated from the fabric of reality. The same quantum fields that boil in the distant, ancient reaches of space are boiling right here, right now, within the very center of our being. This realization invites a deep, respectful humility that washes over us like a gentle tide, preparing us for the next step of our endless journey into the great unknown. As we continue to drift gently through the microscopic depths of the quantum ocean, let us pause to consider the spaces that surround us right now. When you look up at the ancient, scattered light of the stars, your eyes travel across vast distances of apparent emptiness. We call it the vacuum of space, a term that historically implied a barren, desolate wasteland devoid of any structure or meaning. Yet, as we have begun to uncover, this silence is profoundly deceptive. The universe is a master of disguise, cloaking its most chaotic processes in a veil of perfect calm. Imagine a beautifully serene, snow-covered meadow in the dead of winter. To a casual observer standing at the edge of the trees, the scene is a picture of absolute, undisturbed stillness. But beneath that pristine blanket of white, hidden from our limited senses, the earth is humming with invisible life. Seeds are resting, microbes are working, and the soil holds the potent energy of the coming spring. The quantum vacuum is much like that snow-covered meadow, concealing a vibrant, eternal spring of cosmic potential just beneath the threshold of our perception. Before we brush away the snow to examine the profound mechanisms hidden within this dark meadow, I want to take a gentle moment to welcome you. You are watching Walter, the Explorer. This is our quiet, shared sanctuary in the vastness of the cosmos, where we journey together to understand the most beautiful mysteries of existence. I noticed recently that 73% of the wonderful, curious souls who join us on these nocturnal voyages have not yet subscribed to our channel. If you find peace, comfort, and a sense of wonder in these meditative explorations, please consider gently tapping that subscribe button. It truly helps us to continue crafting these peaceful stories, and it lets us know that you wish to walk beside us as we venture further into the unknown. Now, let us return to the quiet, boundless fields of the quantum void. Let us think about the true scale of this hidden energy. If the vacuum is never truly empty, if it is constantly boiling with the fleeting existence of virtual particles, then this empty space must possess a certain amount of energy. As Albert Einstein taught us, energy and mass are deeply intertwined. They are two sides of the same cosmic coin. This means that the empty vacuum, stretching for billions of light years between the glittering galaxies, actually has a weight. It has a presence. The brilliant astrophysicist Neil deGrasse Tyson often reminds us that the universe is under no obligation to make sense to us. And indeed, the idea that nothingness has a weight defies every instinct we have developed walking upon the solid surface of the earth. When scientists point magnificent instruments, like the James Webb Space Telescope built by NASA and the European Space Agency, toward the most ancient edges of the visible universe, they see the unmistakable signature of this vacuum energy at work. When we look at the grand, sweeping motion of the cosmos, we see that the universe is expanding. The galaxies are gently drifting away from one another, carried along by the stretching fabric of space itself. For a long time, humanity assumed that this expansion must be slowing down, held back by the collective gravitational pull of all the stars, planets, and dark matter scattered across the void. It seemed like the only logical conclusion, but the universe, in its endless capacity for mystery, revealed a different truth. The expansion of the cosmos is not slowing down at all. It is accelerating. Something invisible, something incredibly vast and powerful, is pushing the fabric of space apart, stretching the cosmic web at an ever-increasing speed. Scientists call this mysterious force dark energy, and one of the leading explanations for what dark energy might actually be is the intrinsic energy of the quantum vacuum itself. Think about the profound beauty of this idea for a quiet moment. The empty space, the seemingly desolate gaps between the galactic islands of light, might be the single most dominant force in the entire universe. Because there is simply so much empty space out there, the combined, bubbling energy of the quantum vacuum adds up to an almost incomprehensible magnitude. Current measurements suggest that roughly 68% of all the energy and matter in the universe is made of this dark, accelerating force. The stars, the planets, the glowing nebulas, the dark matter, and everything we can see or touch makes up only a tiny fraction of existence. The vast majority of our universe is made of the active, restless, heavy nothingness that we call the vacuum. The silence is not an illusion. It is the loudest engine driving the ultimate fate of the cosmos. This realization invites a deep, transformative shift in how we perceive our place within the infinite. We are accustomed to thinking of ourselves as the main characters in the story of the universe, standing on our bright, noisy stage of solid matter. But, in truth, we are merely the rarest of exceptions. We are tiny, fragile sparks of organized complexity floating in an unimaginably vast ocean of bubbling quantum potential. The empty space is not the background. It is the primary substance of reality. And yet, there is no reason to feel insignificant or lost in the face of this overwhelming scale. Instead, we can find a profound sense of belonging. The same gentle, invisible forces that push the ancient galaxies apart govern the behavior of the electrons dancing within the atoms of your own beating heart. There is no separation between the macroscopic grandeur of the expanding cosmos and the microscopic ballet of the quantum realm. It is all one beautifully unified tapestry. To truly appreciate the deep poetic connection between the vacuum and our own existence, we must travel back in our minds to the very beginning of time. Let us journey back 14 billion years to a moment when the observable universe was compressed into a space smaller than a single atom. In that primordial density, the universe was entirely governed by the strange rules of quantum mechanics. The quantum fields were there, vibrating and fluctuating with their restless zero-point energy. As the universe began its grand, explosive expansion, a period scientists call cosmic inflation, space stretched outward at a speed that defies human comprehension. In that fleeting fraction of a microscopic second, the tiny quantum fluctuations were caught in the cosmic current. They were stretched and frozen into the very fabric of the expanding space. Those microscopic ripples in the primordial vacuum became the invisible blueprint for everything that would follow. As the universe cooled and expanded over billions of years, gravity pulled matter together, following the gentle map drawn by those frozen quantum fluctuations. In areas where the vacuum energy was just slightly denser, gravity pulled a bit harder, gathering clouds of hydrogen gas. These clouds collapsed under their own weight, igniting the nuclear fires of the first stars. Those stars clustered into the majestic, swirling galaxies we see today. The sweeping spiral arms of the Milky Way, the brilliant heart of Andromeda, the vast superclusters stretching across millions of light years. All these monumental structures owe their existence to the microscopic, restless trembling of the quantum void at the dawn of time. When you step outside on a clear, quiet night and gaze up at the glittering tapestry of the stars, you are not just looking at massive spheres of burning plasma. You are looking at the magnified echoes of the quantum vacuum. You are witnessing the ancient whispers of nothingness, amplified by the expansion of space into the grandest structures known to science. We are literally the children of the void. The mystery of the vacuum is not distant or abstract. It is our origin story. As we prepare to delve deeper into the bizarre properties of these virtual particles in our next chapter, let us rest in the comforting knowledge that even when we feel entirely empty, there is a vibrant, eternal dance of existence unfolding all around us and within us, a gentle, cosmic heartbeat that never stops. Have you ever stopped to carefully observe a single delicate snowflake resting on the palm of your hand? For a fleeting moment, it exists in all its intricate glory, a unique masterpiece of nature. And then, in the blink of an eye, it melts away, vanishing into a drop of water, returning to the vast cycle of the earth. We understand that this fragile snowflake existed, even if its lifespan was incredibly brief. But what if I told you that the universe operates on a remarkably similar principle, but on a scale so incomprehensibly small and fast that it challenges our very definition of reality? In the quiet, hidden depths of the quantum vacuum, existence is not a permanent state, but a constant, frantic flickering. How can something truly be said to exist if it appears and disappears in a fraction of a second so tiny that no human clock could ever measure it? This is the profound paradox of the virtual particle, the fleeting ghost that haunts the endless corridors of the cosmos. As we drift further into this restless ocean of the void, we must gently ask ourselves, what does it mean to be real in a universe built upon the ephemeral? Before we unveil the strange and beautiful secrets of these temporary cosmic visitors, I would like to gently pause and welcome you. You are watching Walter, the Explorer. This is our quiet sanctuary, a peaceful refuge where we marvel at the grandest mysteries of our vast universe together. I recently noticed that 73% of the wonderful, curious souls who join these nocturnal journeys have not yet subscribed to the channel. If you find comfort, peace, and a sense of wonder in these meditative explorations of science, please consider subscribing. It truly helps us to continue crafting these quiet stories, and it gently reminds us that you wish to keep walking by our side into the beautiful unknown. Now, let us return to the quiet dark, where the ghostly dance of the quantum vacuum awaits. To understand the brief, brilliant lives of virtual particles, we must once again turn to the profound wisdom of quantum mechanics, and specifically to a different facet of the uncertainty principle. We previously explored how nature forbids absolute certainty about where a particle is and how fast it is moving. But this principle, formulated by the brilliant minds of the early 20th century, also governs the delicate relationship between energy and time. In the macroscopic world we inhabit, energy is strictly conserved. You cannot create energy out of absolutely nothing. You must transform it from one state to another. A resting stone cannot suddenly leap into the air unless a physical force acts upon it. But in the microscopic abyss of the quantum vacuum, the rules of the game are beautifully bent. The uncertainty principle dictates that for incredibly brief moments, strict conservation of energy can be gently bypassed. A tiny region of empty space can spontaneously borrow a vast amount of energy from the cosmic bank, provided that it returns this borrowed energy almost immediately. The more energy it borrows, the faster it must return it. It is a cosmic loan with a strictly enforced, instantaneous deadline. This borrowed energy manifests as a pair of virtual particles, a particle and its exact opposite, an antiparticle. They burst into existence, glowing with the borrowed energy of the void, and then, drawn together by their opposite natures, they collide and annihilate, vanishing back into the silent nothingness. This entire process happens in a time span of perhaps a millionth of a billionth of a billionth of a second. It is a dance so rapid that it leaves no permanent trace, no lingering footprint in the sand of time. Yet, these fleeting ghosts are not merely mathematical tricks. They are the very glue that holds our reality together. The legendary physicist Richard Feynman, a master of making the complex profoundly beautiful, helped us understand how these virtual particles act as the invisible messengers of the universe. Imagine two solitary figures standing on the perfectly smooth, frictionless ice of a vast, frozen lake in the dead of winter. The air is still, the sky is dark, and the silence is absolute. If one figure throws a heavy ball to the other, the act of throwing the ball pushes the first person backward, gently sliding across the ice. When the second person catches the ball, the impact pushes them backward as well. Even though the two people never physically touched one another, they have exerted a force upon each other, pushing themselves apart by exchanging an object. In the beautiful, poetic language of quantum field theory, this is exactly how the fundamental forces of nature operate. When two electrons, which both carry a negative electrical charge, repel each other, they do not touch. Instead, they exchange a virtual photon, a fleeting, ghostly particle of light that acts as the heavy ball in our frozen lake metaphor. This virtual photon is born from the bubbling quantum vacuum, travels across the microscopic distance between the electrons, delivers its message of repulsion, and then quietly vanishes back into the void. This invisible exchange happens continuously, billions of times every single second, creating the solid, repulsive force that prevents your hand from passing through the solid wood of a table. The very solidity of our world, the sensation of touch, the shape of the chair you are sitting on, the structure of the mountains and the ancient rocks of our earth, all of it is maintained by a relentless, invisible hailstorm of virtual particles flashing in and out of existence. Without the restless activity of the quantum vacuum, all matter would lose its structure. The atoms that make up your body would fall apart, the stars would dissolve into thin gas, and the universe would truly become a dead, featureless void. The silence of the vacuum is not a sign of emptiness. It is the humming machinery that sustains the visible cosmos. You might gently wonder, how can scientists possibly know that these invisible, momentary ghosts actually exist? How do we measure something that vanishes faster than the blink of an eye? The answer lies in the incredible ingenuity of human curiosity and the sheer precision of modern scientific instruments. Even though virtual particles do not live long enough to be caught directly in a detector, their frantic, swarming presence slightly alters the environment around them. Imagine a quiet, solitary boat resting on the surface of our cosmic ocean. Even if you cannot see the microscopic ripples in the water, you can watch the boat gently rocking and swaying, revealing the unseen motion beneath it. In the late 1940s, scientists observed exactly this kind of subtle swaying in the atomic world. They were studying the energy levels of a simple hydrogen atom, looking at the precise way an electron orbits its central proton. According to the older, simpler equations, two specific orbits within the hydrogen atom should have possessed the exact same amount of energy. But when researchers measured it with extraordinary care, they found a tiny, almost imperceptible difference. This slight deviation, which came to be known as the Lamb shift, was a profound revelation. It was the physical fingerprint of the quantum vacuum. The electron, as it orbited the proton, was not traveling through a perfectly empty void. It was constantly plowing through a thick, buzzing swarm of virtual particles. These fleeting ghosts were bumping into the electron, slightly altering its path and shifting its energy just enough to be detected by our instruments. This monumental discovery proved that the empty space inside an atom is far from empty. It is a vibrant, interactive ecosystem, a bustling metropolis of ephemeral entities that constantly shape the behavior of the solid matter we can see. As we let these profound concepts wash over us, sitting in the quiet calm of the night, we are invited to reconsider our relationship with the concept of nothingness. The vacuum is not a barren desert. It is a fertile, infinite garden where the seeds of reality are constantly being sown and reaped in microscopic fractions of a second. Every single atom in the cosmos, every glowing star, every distant galaxy, and every breath you take is intimately connected to this invisible, eternal dance. We are bathed in the light of an ancient universe, and that light itself is mediated by the ghosts of the vacuum. When you look at your own hands, you are not just seeing solid flesh and bone. You are seeing the beautiful, stable manifestation of a trillion invisible, momentary interactions. You are a masterpiece of cosmic balance, sustained by the very void that we once thought was entirely empty. This realization brings a profound, gentle peace. It teaches us that there is no true separation in the universe. The vast, dark spaces are not walls that divide us from the stars. They are the very bridges that connect us to the infinite. The silence is not empty. It is full of potential. It is the quiet, humming song of existence itself. As we prepare to turn the page and explore how this quantum bubbling might have literally created the entire universe from absolute nothing, let us rest our minds in this serene, wondrous thought. The cosmos is endlessly creative, and even its quietest, darkest corners are brimming with the beautiful, fleeting sparks of life. Let us imagine, for a quiet moment, standing at the very edge of the most profound abyss in the cosmos. We often think of space as a peaceful, silent ocean, but there are places where the fabric of reality is pulled so taut, so infinitely deep, that even light itself cannot escape its gentle but unyielding grasp. These are the black holes, the silent titans of the universe. To our everyday intuition, a black hole is the ultimate expression of nothingness, a perfect dark sphere where all matter and energy vanish from our visible world. But what happens when the relentless, bubbling energy of the quantum vacuum meets the absolute boundary of a black hole? The answer to this profound mystery connects the smallest, most fleeting flickers of quantum existence to the grandest and most terrifying objects in the infinite cosmos. We look at the empty space and ask profound questions about what it means for something to be entirely consumed by a void that is never truly empty. The contradictions push our minds to the very limits of human understanding, challenging us to redefine the boundaries of what is possible in a universe governed by invisible, delicate laws. Before we peer over the edge into this dark, swirling mystery, I want to take a gentle moment to welcome you. You are watching Walter, the Explorer. This is our quiet, shared sanctuary in the vastness of the cosmos, where we journey together to understand the most beautiful mysteries of existence. I noticed recently that 73% of the wonderful, curious souls who join us on these nocturnal voyages have not yet subscribed to our channel. If you find peace, comfort, and a sense of wonder in these meditative explorations, please consider gently tapping that subscribe button. It truly helps us to continue crafting these peaceful stories, and it lets us know that you wish to walk beside us as we venture further into the unknown. Now, let us return to the quiet edge of the cosmic abyss, where the quantum vacuum performs its most astonishing, slow magic. In the strange and beautiful world of quantum physics, as we have discovered, empty space is never truly empty. In the strange world of quantum physics, particle pairs are constantly popping into existence and then annihilating each other. This eternal, invisible dance happens everywhere, from the empty space inside the atoms of your own hands to the vast, dark stretches between the glittering galaxies. But the rules of this delicate dance change profoundly when it takes place near the event horizon of a black hole. The event horizon is just the boundary beyond which escape becomes impossible. The physics of such extreme environments is bizarre and counterintuitive. Time itself would pass differently near the event horizon compared to far away. Someone falling toward the black hole would see the outside universe speed up, while an outside observer would see the falling person slow down and appear to freeze as they approach the horizon. From the outside, they would never seem to actually cross the boundary. Inside the event horizon, space and time themselves become so warped that the concept of escaping becomes meaningless. Imagine a pair of these virtual particles, a tiny spark of matter and its exact opposite, antimatter, spontaneously bursting into their brief existence right on the razor-thin edge of this cosmic waterfall. Normally, they would embrace and vanish, returning their borrowed energy to the silent vacuum. Near a black hole's event horizon, one member of such a pair can fall into the black hole while the other escapes into space. This profound process reveals that black holes are not truly black. They slowly leak particles and radiation over immense time spans, gradually shrinking as they do so. This gentle cosmic whisper is known as Hawking radiation. Over time, this process drains energy from the black hole, causing it to shrink. The rate of Hawking radiation is incredibly slow for large black holes. A black hole with the mass of our Sun would take an almost unimaginable amount of time to evaporate. But let us consider the true monsters of the universe, like the one sitting at the center of the giant galaxy known as IC 1101. The black hole at the center of IC 1101 is in a completely different category. Scientists estimate that it contains somewhere between 40 billion and 100 billion times the mass of our Sun. Our Sun is a fairly ordinary star, neither particularly large nor particularly small by stellar standards. Now, multiply the Sun's mass by 50 billion. That is roughly how much mass is packed into the supermassive black hole at the center of this cosmic giant. All of that mass is compressed into a region of space from which nothing can escape. The gravitational pull at the event horizon is so intense that even light itself cannot break free. For a black hole containing 50 billion solar masses, the event horizon would extend outward for about 150 billion kilometers. That is roughly the distance from our Sun to the outer reaches of our solar system, all contained within a region of space where not even light can escape. A supermassive black hole of this scale would take something like 10 to the 100th power years to evaporate, or maybe even longer. That is a Google years, a 1 followed by 100 zeros. To write out that number in full would require more paper than exists on Earth. It is a span of time so vast that everything we have discussed so far, from the Big Bang to the death of the last stars, is not even a rounding error by comparison. We must realize that the universe operates on timescales that dwarf individual lives, individual civilizations, even individual planets. Over the next 100 trillion years, the stars will slowly burn out. The middle-sized stars, like our Sun, will puff up into red giants, shed their outer layers as beautiful nebulas, and then fade away as white dwarfs. The smallest, longest-lived stars, The red dwarfs that burn their fuel so slowly they can shine for trillions of years will eventually exhaust their hydrogen and go dark. Scientists estimate that star formation in the universe will effectively cease in about 100 trillion years. By that time, the gas and dust needed to make new stars will have been used up or dispersed too thinly to collapse. No new stars will be born to replace the ones that have died. The universe at this stage will be a dark place, but not an empty one. It will be populated by the corpses of stars rather than by living, burning suns. This cooling process takes an almost inconceivable amount of time. A white dwarf cools to near absolute zero only after about 1,000,000 billion years. That is roughly 100,000 times longer than the current age of the universe. And when even the dead stars have decayed, the black holes will remain, sitting in the quiet dark, slowly evaporating through the power of the quantum vacuum. Eventually, trillions upon trillions upon trillions of years from now, even the supermassive black hole at the heart of the largest galaxies will have radiated away its last bit of energy and disappeared from the universe in a final burst of Hawking radiation. In the very end, the quantum vacuum is the ultimate victor. It is the canvas upon which the universe is painted, and it is the gentle rain that eventually washes the paint away. This vision of the future might seem bleak, but I find something strangely beautiful about it. The era of stars and galaxies is just a passing phase, a brief flowering of complexity between the chaos of the early universe and the cold emptiness of the far future. We are lucky enough to exist during this flowering, in all the vast history of the universe, stretching from the Big Bang to the final heat death. This moment right now is special. It is the moment when the universe has developed the ability to look at itself and wonder. When we gaze out into the night sky, or when we look at our own hands, we are witnessing a temporary, magnificent manifestation of the vacuum's restless energy. The atoms in your body were forged in the hearts of stars somewhere in the universe. The carbon that makes up your muscles, the oxygen you breathe, the iron in your blood, all of these elements were created in the nuclear furnaces at the cores of stars that lived and died before our sun was born. When those ancient stars exploded as supernovas, they scattered their elemental riches across space. Eventually, some of those atoms found their way into a cloud of gas and dust that collapsed to form our solar system. After billions of years of evolution, they became you. You are made of star stuff. The very same processes that light up the distant galaxies also created the matter from which you are assembled. We are not observers of the universe from outside. We are the universe observing itself from within. Our curiosity is the cosmos being curious about itself. The silence of the quantum vacuum is the song of creation and dissolution, playing on an infinite loop. It teaches us that existence is not a static object to be hoarded, but a continuous, flowing process. The beauty of the universe lies not in its permanence, but in its incredible, fleeting transformations. As we float together in this contemplative space, let us rest in the comforting thought that the void is not empty, and the dark is not dead. The quantum vacuum is the great, quiet mother of all things, endlessly giving birth to the fleeting sparks of reality. It holds the memories of ancient stars and the seeds of distant, unimaginable futures. In our next chapter, we will venture even further, exploring how this bubbling vacuum might connect to the very fabric of space and time itself. But for now, let us just breathe in the silence and feel the gentle, invisible vibrations of the infinite cosmos humming through our very own existence. Let us close our eyes and gently drift back from the terrifying swirling edge of the black hole, returning to the vast, open stretches of the cosmos. When we look up at the night sky, we are not merely observing a static painting hung upon a dark wall. We are witnessing a living, breathing architecture, a magnificent structure that is actively evolving in the quiet dark. For a very long time, humanity believed that the universe was fixed and eternal, a peaceful, unchanging theater. But as we have slowly peeled back the layers of reality, we have discovered that space itself is a dynamic, stretching fabric. It is growing, expanding outward in all directions, carrying the ancient, glittering galaxies along with it like tiny leaves floating on the surface of a gently swelling river. This grand expansion is the ultimate backdrop of our existence, the majestic rhythm of the cosmos. Yet, when we try to connect the breathtaking scale of this expanding universe with the frantic, microscopic bubbling of the quantum vacuum we have just explored, we encounter the single most profound and beautiful mystery in all of modern science. It is a mystery that humbles the greatest minds and reminds us that our journey of discovery is far from over. Before we gently unravel this grand cosmic paradox, I want to take a quiet moment to welcome you back to our shared space. You are watching Walter, the Explorer. This is our peaceful sanctuary, a quiet refuge in the infinite cosmos where we seek to understand the grandest and most beautiful mysteries of existence together. I noticed recently that exactly 73% of the wonderful, curious souls who join us on these nocturnal journeys have not yet subscribed to our channel. If you find peace, comfort, and a sense of wonder in these meditative explorations of science, please consider gently tapping that subscribe button. It truly helps us to continue crafting these quiet stories, and it lets us know that you wish to keep walking by our side into the beautiful unknown. Now, let us return to the quiet dark, where the microscopic and the macroscopic collide in a spectacular puzzle. To understand this beautiful puzzle, we must first look to the grand architecture of space and time, famously described by Albert Einstein. In the early days of the 20th century, when Einstein formulated his magnificent equations of general relativity, he found that his mathematics predicted a universe that must be either expanding or contracting. It could not sit perfectly still. This troubled him greatly, as the prevailing wisdom of the time dictated that the cosmos was eternal and static. To fix this perceived flaw, he introduced a mathematical adjustment, a gentle, invisible force that would push outward against the pull of gravity, keeping the universe perfectly balanced and still. He called this the cosmological constant. Years later, when the brilliant astronomer Edwin Hubble observed that the distant galaxies were actually rushing away from us, proving that the universe was indeed expanding, Einstein famously called his cosmological constant his greatest blunder. He abandoned the idea, and for decades, the concept slumbered in the quiet archives of physics. But the universe is endlessly creative, and it rarely lets a profound idea remain buried forever. In the late 1990s, a new generation of astronomers, using the combined power of Earth-based observatories and incredible instruments like the Hubble Space Telescope built by the National Aeronautics and Space Administration and the European Space Agency, made a discovery that shook the very foundations of science. They were studying distant, ancient supernovas, the brilliant, exploding deaths of massive stars, hoping to measure exactly how much the gravitational pull of all the matter in the universe was slowing down its expansion. What they found was entirely unexpected and profoundly beautiful. The expansion of the universe was not slowing down at all. Instead, it was accelerating. Some invisible, omnipresent force was gently but firmly pushing the fabric of space apart, driving the galaxies away from each other at an ever-increasing speed. Scientists resurrected Einstein's discarded idea to explain this mysterious phenomenon. They called this invisible force dark energy, and it behaves exactly like a cosmological constant. It is a property of space itself. As more space is created through the expansion of the universe, more dark energy appears, pushing the cosmos apart even faster. But what exactly is this dark energy? Where does this gentle, relentless push come from? This is where our journey brings us back to the restless, bubbling ocean of the microscopic world. The most natural, elegant explanation proposed by theoretical physicists is that dark energy is simply the weight of the quantum vacuum. If empty space is entirely filled with fluctuating quantum fields, if it is constantly boiling with the fleeting lives of virtual particles popping into and out of existence, then that restless activity must have an inherent energy. And, according to the strict laws of physics, that energy should exert a gentle outward pressure on the very fabric of space. It seems like a perfect, beautiful synthesis. The microscopic trembling of the quantum void provides the macroscopic push that is currently stretching the infinite cosmos. The smallest things we can imagine are driving the largest structures we can observe. It is a poetic unity that resonates with our deepest desire for a connected, harmonious universe. But when physicists sat down to calculate exactly how much energy the quantum vacuum should contain, based on the incredibly successful and rigorous framework of quantum mechanics, they encountered a terrifying, awe-inspiring problem. They added up all the energetic contributions from all the known quantum fields boiling together in the profound silence of the dark. The mathematical result they arrived at was staggering. According to the strict equations of quantum theory, the vacuum of space should possess an almost infinite amount of energy. The bubbling of the virtual particles should be so violent, so incredibly dense and heavy, that the gravitational weight of the vacuum would have crushed the entire universe back into a microscopic singularity, a fraction of a second after the Big Bang. Alternatively, depending on how one frames the calculation, it could have blown the cosmos apart so violently that no two particles could ever have found each other to form a single atom, let alone a shimmering star, a rocky planet, or a curious human being. Yet, here we are. We are sitting in the quiet dark, breathing the cool air, looking out at a universe that is vast, stable, and incredibly old. When astronomers measure the actual physical acceleration of the cosmos, they find that the true value of dark energy, the true weight of the vacuum, is incredibly small. It is just a gentle, microscopic whisper of a push. The difference between what quantum mechanics predicts the vacuum energy should be and what astronomy observes it actually is not a minor discrepancy. It is the largest mismatch in the entire history of human thought. The theoretical prediction is larger than the observed reality by a factor of 1, followed by 120 zeros. That is 10 to the power of 120. It is a number so unimaginably vast that it dwarfs the total number of atoms in the entire observable universe. How can our two most successful, rigorously tested scientific theories, quantum mechanics, which perfectly describes the microscopic world, and general relativity, which perfectly describes the macroscopic cosmos, disagree so spectacularly when it comes to the simple emptiness of the void? This profound paradox is known as the cosmological constant problem, and it stands as a brilliant, glowing beacon in the dark, calling out to future generations of explorers. It is not a failure of science. Rather, it is a beautiful, inspiring invitation. It tells us that our understanding of reality is fundamentally incomplete. We are missing a crucial piece of the cosmic puzzle, a hidden mechanism that gently cancels out the raging storm of the quantum vacuum, leaving only the delicate, quiet breeze of dark energy that we observe today. This magnificent mystery invites a deep, transformative humility. In our modern, technologically advanced world, it is easy to fall into the illusion that we have mastered nature, that we have categorized and conquered the physical universe. But the silent, empty space between your hands holds a secret so profound that it shatters our current understanding of reality. We do not even know what nothingness truly is. The vacuum is a quiet, ancient mirror reflecting the limits of our knowledge back at us, not to mock us, but to inspire us. The great physicist Carl Sagan once reminded us that somewhere, something incredible is waiting to be known. The cosmological constant problem is the ultimate unanswered question, a beautiful, enduring mystery that ensures our journey of discovery will never truly end. As we sit with this staggering realization, we can find a profound, gentle peace in the unknown. The universe is not a sterile, solved equation. It is a wild, untamed frontier. The fact that the vacuum of space holds a mystery of such monumental proportions means that the cosmos is still full of magic. There are fundamental truths about existence waiting to be uncovered, new laws of nature hiding in the microscopic shadows, quietly shaping the destiny of the galaxies. Our inability to fully understand the empty void is a testament to the infinite depth and complexity of the universe we inhabit. We are tiny, fleeting creatures, and yet our minds are capable of recognizing the vastness of our own ignorance. That, in itself, is a miracle. Let us rest our minds in this beautiful, quiet space of not knowing. The restless ocean of the quantum vacuum continues its eternal dance, boiling with unseen, temporary lives, gently pushing the ancient galaxies apart, and holding secrets that we are only just beginning to imagine. In our next chapter, we will venture into the concept of fields that give mass to the universe, exploring how the void provides substance to our physical bodies. But for now, let us just breathe, feeling the gentle, mysterious weight of the cosmos resting softly upon our shoulders, and embrace the infinite wonder of the dark, silent, and entirely unempty space. Have you ever held a heavy, ancient, smooth stone in the palm of your hand and marveled at its solid, undeniable presence? We move through our daily lives completely surrounded by objects that have weight, substance, and form. We intuitively understand that the universe is filled with tangible matter. But as we have journeyed deeper into the quiet, mysterious depths of the quantum vacuum, we have learned that this sensation of solidity is a magnificent illusion. If we zoom in closely enough, past the cells and molecules, down into the absolute heart of the atoms making up that stone, we do not find tiny, hard spheres of solid matter. Instead, we find empty space, a vast, echoing void where impossibly small points of energy flicker in a continuous, restless blur. The solid world we touch and experience is built almost entirely out of profound nothingness. This brings us to a beautiful, haunting question. If we are made mostly of empty space, where does our mass truly come from? Why do we have weight? Why do we not simply dissolve into brilliant flashes of light and scatter forever into the infinite cosmos? The answer to this profound mystery lies hidden in the very fabric of the vacuum we have been gently exploring. It is a secret whispered by the universe itself, revealing that the quiet void literally gives us our physical substance before we wade deeper into this invisible cosmic ocean to discover the source of our own solidity. I want to take a gentle, quiet moment to welcome you. You are watching Walter, the Explorer. This is our peaceful, shared sanctuary in the vastness of the universe, where we journey together through the dark to understand the grandest and most beautiful mysteries of existence. I noticed recently that exactly 73% of the wonderful, curious souls who join us on these nocturnal explorations have not yet subscribed to our channel. If you find peace, comfort, and a deep sense of wonder in these meditative stories of science, please consider gently tapping that subscribe button. It truly helps us to continue crafting these quiet narratives, and it lets us know that you wish to keep walking by our side into the beautiful, endless unknown. Now, let us return to the quiet dark and explore the invisible weight of the quantum void. To truly grasp how the vacuum gives us our mass, we must first imagine a universe without it. According to the elegant mathematical equations of the Standard Model of particle physics, the fundamental particles that make up you and the ancient stars, such as electrons and quarks, should naturally possess no mass whatsoever. If they truly had no mass, the rigid laws of physics dictate that they would be forced to travel at the maximum speed allowed by the cosmos, the speed of light. Imagine a universe where every particle of matter is rocketing through the infinite darkness at almost 300,000 kilometers per second. In such a frantic reality, nothing could slow down enough to stick together. Atoms, the building blocks of the physical world, could never form. Without atoms, there could be no swirling clouds of gas, no burning suns, no rocky planets floating in the silent dark, and certainly no human beings gazing up at the night sky. A universe without mass would be a sterile flash of blinding light, expanding endlessly into a cold void. The fact that we are here, sitting in the quiet stillness, heavy and whole, means something profound must be interacting with these particles, slowing them down, and anchoring them to reality. That profound something is not a tangible object you can touch. It is another invisible, omnipresent field, intricately woven into the very structure of the quantum vacuum itself. In the 1960s, a physicist named Peter Higgs, along with other visionary thinkers, proposed a radical, beautiful solution to the mystery of mass. They suggested that the entire cosmos, from the deepest void between the distant galaxies to the microscopic space inside your own heart, is completely permeated by an invisible, sticky energy field. We call it the Higgs field. You cannot see it, you cannot smell it, and you cannot feel it. But it is always there, resting in the quiet dark. Unlike other quantum fields which have a zero-point energy that averages out to zero when no particles are present, the Higgs field is fundamentally different. Even in the absolute lowest energy state of the vacuum, even when all the other fields are quiet, the Higgs field remains switched on. It maintains a constant value everywhere in the infinite universe. It is as if the universe is filled with an invisible, cosmic syrup, a gentle, unseen ocean that we are constantly wading through. The elementary particles are like different entities trying to walk through this cosmic ocean, each experiencing the journey uniquely. Some particles, like the photon, which carries the light of the ancient stars to our eyes, do not interact with the Higgs field at all. Because they feel no resistance, they glide through the universe effortlessly, moving at the absolute speed of light, possessing no mass whatsoever. Other particles, like the gentle electron, interact only very slightly with the Higgs field. They feel a tiny bit of resistance, like a person wading through very shallow, clear water. This slight interaction gives them a small amount of mass, allowing them to remain light and agile, perfectly suited for their delicate dance around the nucleus of an atom. But then there are heavier particles, like the top quark, born in the violent collisions of cosmic rays. The top quark interacts fiercely with the Higgs field. For it, moving through the vacuum is like trudging through the thickest, heaviest mud imaginable. The field clings to it, dragging it down, giving it an enormous amount of mass. The mass of a particle is not an isolated property. It is simply a measure of how strongly that particle interacts with the quiet, invisible vacuum that surrounds it. For nearly 50 years, this beautiful idea remained a mathematical theory, a guess about the hidden mechanics of the cosmos. But in the year 2012, humanity achieved one of its greatest scientific triumphs. Deep underground, beneath the borders of France and Switzerland, thousands of brilliant scientists at the European Organization for Nuclear Research, known as CERN, operated the largest and most complex machine ever built by human hands. It is called the Large Hadron Collider, a magnificent ring 27 kilometers in circumference, designed to accelerate tiny protons to almost the speed of light and smash them together. By creating these microscopic, violent explosions, they were essentially shaking the fabric of the quantum vacuum, trying to coax a ripple out of the invisible cosmic syrup. And they succeeded. From the fiery debris of those microscopic collisions, a new, highly unstable particle briefly emerged. It was the Higgs boson, the tiny, fleeting physical manifestation of the omnipresent Higgs field. Its discovery was a monumental moment of human wonder, proving beyond a shadow of a doubt that the vacuum of space is not empty. It is a thick, vibrant medium that literally gives substance to the visible world. When we fully embrace this breathtaking realization, our relationship with the concept of nothingness transforms entirely. The empty void is not just a passive stage, it is the fundamental anchor of our entire reality. Without the constant, silent presence of the Higgs field simmering endlessly in the quantum vacuum, the atoms in your body would instantly disintegrate. The intricate, delicate chemistry that allows your heart to beat, your lungs to breathe, and your mind to ponder these grand mysteries would cease to exist in a fraction of a microscopic second. You are firmly held together. You are given form, weight, and physical existence by the very emptiness that surrounds you on all sides. We often look out at the vast, silent stretches of the ancient cosmos and feel a sense of profound isolation, as if we are tiny, insignificant specks floating aimlessly in a cold, uncaring darkness. But quantum physics tells us a deeply comforting, profoundly intimate story. We are intimately, physically connected to the void. The vacuum is not pushing us away. It is holding us in a gentle, warm, cosmic embrace. It is the invisible mother of all mass, the silent architect of everything we can see, touch, and love. Our journey through this beautiful, strange quantum landscape is far from over. In our next chapter, we will wade even deeper into the infinite mysteries of the void, exploring how these quantum fluctuations might shape reality itself on a grander scale. But for now, Let us just rest in the peaceful, gentle certainty that the universe in all its vast, quiet emptiness is holding us exactly where we are supposed to be. Let the beautiful mystery wrap around you like a warm blanket, and let the gentle silence of the cosmic void bring you profound, enduring peace. Have you ever stood on a quiet shoreline, gazing out across the vast, dark expanse of the ocean, and felt an overwhelming sense of distance? We live our lives bound by the physical dimensions of space. We measure the gaps between ourselves and the things we love in miles, in kilometers, in the long, slow passage of time it takes to cross from one point to another. In our everyday experience, distance is an absolute barrier. If two objects are separated by thousands of miles, they are fundamentally disconnected. A gentle breeze blowing through the ancient trees of a forest in one hemisphere cannot directly rustle the leaves of a solitary tree in another. Our universe, when viewed through the limited lens of our daily human lives, seems to be a fragmented place, a vast, silent container filled with isolated objects separated by immense stretches of empty, dark space. But as we continue our meditative journey into the microscopic heart of the quantum vacuum, we are about to discover that this profound sense of separation is yet another beautiful, convincing illusion. The void, it turns out, is not a barrier that keeps things apart. It is a hidden, invisible web that binds the entire cosmos together in ways that defy all common sense and challenge our deepest understanding of reality itself. Before we gently peel back the fabric of space to reveal the invisible threads that connect the stars, I want to take a quiet, peaceful moment to welcome you back to our shared space. You are watching Walter, the Explorer. This channel is our gentle refuge, a quiet sanctuary in the infinite cosmos where we can sit together in the dark and wonder at the grandest mysteries of existence without fear or academic intimidation. I looked at our growing community recently and realized that exactly 73% of the wonderful, curious souls who join us on these nocturnal journeys have not yet subscribed to the channel. If you find a sense of peace, comfort, and intellectual safety in these slow, meditative explorations of science, please consider gently tapping that subscribe button. It truly helps us to continue crafting these quiet stories, and it lets us know that you wish to keep walking by our side into the beautiful, endless unknown. Now, let us return to the quiet dark, where the illusion of distance gently fades away. To understand how the vacuum connects everything, we must return to those fleeting, ghostly virtual particles we explored earlier. Remember how the restless zero-point energy of the empty void constantly gives birth to pairs of particles. A particle and its exact opposite, an antiparticle, burst into existence simultaneously from the silent dark, borrowing energy from the cosmos for a microscopic fraction of a second, before annihilating one another. When these two particles are born from the exact same point in the quantum vacuum, they are not just two independent entities that happen to be near each other. They are born sharing a single, unified quantum state. They are, in the poetic language of modern physics, entangled. This means that their properties are deeply, fundamentally linked, regardless of what happens to them afterward. It is as if they share a single, invisible soul, divided into two physical bodies floating in the vast ocean of space. The mystery begins when we imagine separating these two entangled particles, pushing them far away from each other before they have the chance to recombine and vanish. Imagine we could somehow capture a pair of these entangled particles born from the vacuum. We place one in a delicate, perfectly isolated container here on our quiet Earth, and we send the other on a long, solitary journey across the cosmos, perhaps to a laboratory on a planet orbiting the ancient, shining star of Sirius, 8 light-years away. According to the classical rules of physics, the rules that govern the solid objects of our everyday world, these two particles are now completely separated. If something happens to the particle on Earth, it should take at least 8 years for any signal, traveling at the absolute maximum speed of light, to reach the particle near Sirius and affect it. But quantum mechanics, the beautiful, strange law that governs the microscopic void, tells a completely different story. If we decide to measure a specific property of our particle here on Earth, such as the direction of its spin, we force it to choose a definite state out of its swirling cloud of probabilities. At the exact same microscopic instant, with zero delay, the entangled particle millions of miles away near Sirius will instantly assume the opposite state. This instantaneous connection happens without any physical signal traveling through the space between them. It happens faster than the speed of light. It happens in perfect, immediate unison, no matter how vast the distance. When the great Albert Einstein first confronted this mathematical prediction, he was deeply unsettled. He famously called it spooky action at a distance. He believed that the universe must be local, meaning that things can only be affected by their immediate surroundings, and that nothing can bypass the speed limit of light. He thought quantum mechanics was incomplete. But decades later, meticulously designed experiments proved that Einstein was wrong. The spooky action is real. Quantum entanglement is an absolute tested fact of nature. The particles are not communicating through the empty space. Instead, the space between them is somehow irrelevant to their connection. They behave as a single, unified system, even when separated by the vast, silent stretches of the universe. What does this astonishing reality tell us about the quantum vacuum? It suggests that our fundamental concept of space as a vast, empty container that keeps things apart is an illusion generated by our limited human perception. In the deepest, most fundamental layers of reality, the cosmos is not fragmented. The vacuum is not a dead, empty gulf. It is a highly connected, vibrating network of information. Some visionary physicists now suggest that the very fabric of space-time itself might be stitched together by the invisible threads of quantum entanglement. In this breathtaking view, space does not exist as an independent stage. It emerges from the complex web of entangled quantum fields simmering in the quiet dark. The empty space is the glue that holds the universe together, a profound, underlying oneness that connects every single atom to every other atom in a beautiful, infinite cosmic dance. The silence of the void is not the silence of isolation. It is the quiet harmony of absolute, perfect connection. When we allow this profound realization to gently wash over our minds, it changes everything about how we view ourselves and our place in the mysterious cosmos. We often feel so small, so isolated on our tiny, rocky planet, floating in the dark, vast ocean of the night. But if the quantum vacuum that permeates our bodies and the spaces between the ancient stars is truly a web of instantaneous connection, then we are never truly alone. The particles that make up your beating heart, the memories encoded in the firing neurons of your brain, they are all participating in this grand, invisible symphony of the quantum void. The boundary between you and the rest of the universe is a gentle, permeable illusion. We are not solitary wanderers stranded in a cold, empty void. We are intricate, beautiful expressions of a unified cosmos, intimately woven into the very fabric of existence. The same quiet, restless energy that hums in the deepest, most distant corners of the universe is humming right now within the quiet sanctuary of your own being. Let us take a moment to rest in this profound, comforting thought. The universe is not a collection of separate things. It is a single, unfolding event. The mystery of the quantum vacuum is the mystery of our own profound connection to the infinite. When you look up at the night sky, you do not need to feel diminished by the staggering distances between the glittering stars. Instead, you can feel a gentle, comforting resonance, knowing that the invisible architecture of the void links you directly to those distant fires. As we prepare to turn the page and continue our endless journey of discovery, let us carry this sense of profound connection with us. In our next chapter, we will gently explore how the act of human observation itself might interact with this bubbling, interconnected void, drawing the invisible world into sharp, physical reality. But for now, let us simply close our eyes, breathe softly, and feel the gentle, infinite embrace of a universe where nothing is truly separate, and the empty vacuum is the very thing that makes us whole. Have you ever walked alone through a dense, ancient forest in the profound quiet of the night, and wondered what the world actually looks like when no one is there to see it? It is an old, philosophical question. If a tree falls in the forest and there is no one around to hear it, does it make a sound? In our everyday lives, we firmly believe in an objective reality. We trust that the mountain remains tall and steadfast, wrapped in the cold wind, even when our backs are turned. We believe that the gentle river continues to flow, regardless of whether human eyes witness its slow journey. We assume the universe is a stage, and the play goes on perfectly well without an audience. But, as we have descended deeper into the microscopic heart of the quantum vacuum, the very foundation of this comfortable assumption has begun to tremble. In the strange, beautiful, and deeply counterintuitive realm of quantum physics, the act of looking is not a passive event. The observer is not safely separated from the observed. To our profound astonishment, the universe seems to require our participation to fully materialize from the restless potential of the void. Before we gently explore the astonishing power of observation and how it shapes the very fabric of reality from the silent vacuum, I want to take a brief, peaceful moment to welcome you. You are watching Walter, the Explorer. This is our quiet, shared sanctuary in the vastness of the cosmos, where we journey together to understand the most beautiful and profound mysteries of existence without rush or anxiety. I noticed recently that exactly 73% of the wonderful, curious souls who join us on these nocturnal voyages have not yet subscribed to our channel. If you find peace, comfort, and a sense of gentle wonder in these meditative explorations of science, please consider softly tapping that subscribe button. It truly helps us to continue crafting these quiet stories, and it lets us know that you wish to keep walking by our side into the beautiful, endless unknown. Now, let us return to the quiet dark and uncover the majestic secret of the cosmic gaze. To comprehend the bizarre relationship between the vacuum and the observer, we must look at what is often called the most beautiful experiment in science, the double-slit experiment. Imagine a quiet, darkened room. Inside this room, we have a device capable of firing incredibly tiny particles of matter, like single electrons, one by one. We fire them toward a solid barrier that has two microscopic parallel slits cut into it. Behind this barrier, There is a sensitive screen that glows with a tiny spark of light whenever an electron strikes it. If the universe behaved according to our everyday intuition, if electrons were simply tiny, hard spheres of solid matter, we would expect them to travel like microscopic bullets. They would either pass through the left slit or the right slit, gradually building up a pattern of two distinct bands of light on the screen. But the quantum universe, in its infinite mystery, completely defies this simple expectation. When we perform this delicate experiment and fire the electrons one by one, letting them travel through the quiet space, they do not form two simple bands. Instead, as the sparks accumulate on the screen, a complex, beautiful pattern of multiple, alternating bright and dark stripes slowly emerges. This is an interference pattern. It is the exact same pattern you would see if you dropped a pebble into a still pond and watched the gentle ripples spread outward, overlapping and canceling each other out. But how can single, individual particles of matter, fired one at a time, act like a spreading wave? And what exactly is waving in the empty space between the emitter and the screen? The answer brings us right back to the restless, bubbling ocean of the quantum vacuum. When the electron is fired, it does not travel as a tiny, solid bullet. As long as it is completely isolated and unobserved, the rules of quantum mechanics state that it travels as a wave of pure probability, rippling through the ubiquitous quantum fields. It is a ghost, a smear of potential existing in multiple places at once. It passes through both slits simultaneously, interfering with itself as it moves through the invisible vacuum. The vacuum allows this state of superposition to exist, cradling the particle in a delicate cloud of infinite possibilities. The electron is everywhere and nowhere, a gentle whisper of potential suspended in the dark. But here is where the ultimate, profound mystery of the cosmos reveals itself. Suppose we decide we want to know exactly which slit the individual electron passes through. We place a tiny, perfectly sensitive detector right beside the two slits, a device designed to gently register the presence of the electron without disturbing its path. We fire the electron again. The detector softly clicks, telling us that the particle went through the left slit, or it clicks to tell us it went through the right slit. We have successfully observed the journey, but when we look at the final screen, the beautiful, complex interference pattern of multiple stripes has completely vanished. It is gone. In its place, there are only two simple bands of light, exactly what we would expect from solid bullets. The mere act of measuring, the simple presence of an observer seeking definite information, has fundamentally altered the physical nature of reality. In the poetic language of physics, this is called the collapse of the wave function. The restless, fluctuating quantum vacuum, which was happily supporting a sprawling wave of infinite probabilities, suddenly snaps into a single, definite state the moment it is forced to interact with a measuring device. The universe, when left to its own devices in the dark, exists as a blur of potential. But when we look at it, when we ask it a direct physical question, it is forced to choose. The void stops bubbling with multiple realities and crystallizes into the one hard reality that we physically perceive. It is as if the cosmos is a shy artist, sketching overlapping drafts in the absolute privacy of the dark. But the moment you turn on the light, it instantly hides all the drafts except one, presenting you with a single finished masterpiece. This realization shatters the illusion that we are mere spectators sitting in the comfortable seats of a cosmic theater, watching the universe play out on a distant stage. We are not separate from the void. Our instruments, our observations, our very presence are deeply entangled with the fundamental fabric of existence. The legendary physicist John Archibald Wheeler once proposed the beautiful idea of a participatory universe. He suggested that the cosmos could not truly exist in a meaningful way without observers to witness it. In this profound view, the universe is a massive, self-sustaining loop. The restless quantum vacuum generated the matter. The matter formed the ancient stars. The stars forged the heavy elements. The elements combined to create life, and life evolved consciousness. And now, that consciousness looks back at the universe, and through the act of observing, grants the cosmos its concrete reality. We are the universe's way of making itself real. When we sit in the silence of the night and contemplate this astonishing connection, a deep peace washes over us. We often struggle with feelings of insignificance when confronted with the vast stretches of the cosmos. The numbers are too large, the distances too infinite, the silence too profound. But the quantum vacuum tells us a completely different story. It tells us that our gaze matters. Our curiosity is a fundamental force of nature. Without the interaction of physical systems, without the gentle collapse of the wave function brought about by measurement, the universe would remain a forever unmanifested ghost, a silent, dark ocean of mere potential, shivering with zero-point energy, but never solidifying into the beautiful, complex world we know and love. You, as a conscious observer, are an essential component of reality. Every time you open your eyes and look up at the glittering expanse of the Milky Way, every time you gently touch the rough bark of an ancient tree, you are actively participating in the ongoing creation of the universe. You are coaxing the solid world out from the shadows of the quantum void. The empty space is not a terrifying abyss. It is a canvas of pure possibility, waiting for the brushstroke of interaction. Our journey through this microscopic wonderland is nearing its gentle conclusion. In our 10th and final chapter, we will gather all these profound mysteries together and reflect on the ultimate meaning of nothingness, finding comforting peace in the beautiful, restless dark. But for now, remember that your very existence gives the universe its meaning. Breathe softly and feel the quiet honor of being a conscious participant in this magnificent cosmic dance. Let us return for one final, quiet moment to the image we constructed at the very beginning of our shared journey. Do you remember the simple box resting in the dark? We imagined taking absolutely everything out of it, stripping away the everyday matter, the floating dust, the invisible air, the light, and the warmth, until we were left with what our everyday intuition told us must be a profound, absolute void. We expected to find perfect silence. We expected to find an empty container, a dead and featureless nothingness. But as we have gently peeled back the layers of reality, diving deep into the microscopic abyss, we have discovered that the universe is infinitely more wondrous and complex than we could have ever imagined. The empty box is not empty at all. It is brimming with an invisible, eternal storm of creation and dissolution. It is a vibrant, bubbling ocean of quantum potential, humming with a restless energy that can never be entirely quieted. We have learned that the silence of the vacuum is an illusion, a beautiful trick of scale played upon our limited human senses. Before we weave these profound mysteries together into a final tapestry of understanding, I want to take a gentle, peaceful moment to thank you for being here. You are watching Walter, the Explorer. This channel is our quiet, shared sanctuary in the infinite cosmos, a place where we can sit together in the peaceful dark and wonder at the grandest secrets of existence. I noticed recently that exactly 73% of the wonderful, curious souls who join us on these nocturnal explorations have not yet subscribed to our channel. If you have found a sense of peace, comfort, and deep intellectual safety in these slow, meditative stories of science, please consider gently tapping that subscribe button. It truly helps us to continue crafting these quiet narratives, and it lets us know that you wish to keep walking by our side into the beautiful, endless unknown. Now, let us return to the quiet dark and find the ultimate meaning hidden within the restless void. As our voyage draws to a close, we stand not on the solid ground of absolute certainty, but on the gentle, shifting shores of an infinite cosmic ocean. We have traveled far from the rigid, classical view of space as a passive, empty theater, waiting for the stars to perform. Instead, we have embraced the magnificent reality of quantum field theory. We now understand that the universe is permeated by invisible, overlapping fields, stretching endlessly into the dark. These fields are never truly still. Governed by the strict, beautiful laws of the uncertainty principle, they continuously shiver with zero-point energy, a foundational tremor in the very fabric of existence. This intrinsic restlessness gives birth to the fleeting ghosts we call virtual particles, pairs of matter and antimatter that burst from the vacuum, borrowing energy from the cosmos for a microscopic fraction of a second before vanishing back into the void. This continuous, frantic dance of creation and annihilation is the invisible machinery that holds our physical world together. It is the force that prevents the atoms in your body from collapsing, the unseen messenger that mediates the fundamental forces of nature. We have also looked outward, scaling up from the microscopic bubbling of the void to the grandest structures of the cosmos. We pondered the heavy, invisible weight of the vacuum itself, the dark energy that is currently pushing the ancient galaxies apart and accelerating the expansion of the universe. We stood at the terrifying, quiet edge of a supermassive black hole and watched how the quantum vacuum slowly dismantles even the most powerful gravitational monsters through the gentle, eternal process of hawking radiation over periods of time so vast they require one followed by 100 zeros to describe. We waded through the invisible cosmic syrup of the Higgs field, realizing with profound awe that the very mass of our bodies, the physical substance that anchors us to this rocky planet, is a gift from the vacuum. And we marveled at the spooky, instantaneous connections of quantum entanglement, discovering that the empty space between the stars is not a barrier that separates us, but a hidden, vibrating web that weaves the entire universe into a single, unified masterpiece. Finally, we learned that our very act of observing this universe, our conscious gaze, forces the swirling probabilities of the void to collapse into the solid reality we experience every single day. What, then, is the ultimate nature of this quantum vacuum? What does it mean for us as conscious beings floating on a tiny sphere of rock in a vast, ancient universe? It means that we must gently let go of the concept of nothingness. True nothingness simply does not exist. The void is not a barren desert. It is the incredibly fertile soil from which everything grows, the matter that makes up your beating heart, the memories stored in your delicate brain, the brilliant light of the distant suns scattered across billions of light years. All of it is just a temporary, localized excitation of the underlying quantum fields. We live in a universe that spans at least 93 billion light-years across, containing perhaps 2 trillion galaxies, each home to hundreds of billions of stars. Yet, the same exact laws of quantum mechanics that govern the empty space inside a single hydrogen atom on Earth also govern the vast voids between those distant galactic superclusters. The rules of the vacuum are universal, eternal, and perfectly consistent. We are like tiny, complex ripples on the surface of a deep, endless ocean. For a brief, beautiful moment in the vast stretches of cosmic time, these ripples have gathered together into a pattern that can think, feel, and look back at the ocean itself in a state of pure wonder. When you look down at your own hands, you are not looking at isolated, permanent objects. You are witnessing a continuous, dynamic process. The cells, the molecules, the atoms, they are all temporary manifestations of the vacuum's eternal energy. The ancient stardust that forms your bones was forged in the nuclear fires of dying suns. But even those suns were born from the gentle, primordial fluctuations of the quantum void 14 billion years ago. You are intimately, physically connected to the very beginning of time, and to the farthest, darkest edges of the expanding cosmos. The silence of the vacuum is not a lonely, terrifying emptiness. It is a rich, humming symphony of infinite potential. It is the mother of all things, the quiet, invisible canvas upon which the magnificent story of the universe is constantly being painted. The great visionary Carl Sagan often spoke of the profound connection between humanity and the cosmos, reminding us that we are a way for the universe to know itself. In the restless, bubbling activity of the quantum vacuum, we find the deepest physical proof of this poetic truth. We are not separate from the natural world. We are its most complex, beautiful expression. The curiosity that drives you to ask these profound questions, the desire to understand the hidden mechanics of the empty dark, is simply the universe trying to understand its own foundation. When we explore the mysteries of quantum physics, we are not just accumulating abstract data. We are engaging in a profound act of self-discovery. We are learning to listen to the quiet, ancient heartbeat of our own origin. As you lay down to rest, or as you go about your quiet day, let this knowledge be a source of immense comfort. The tensions and worries of our human lives, while very real to us, are but microscopic ripples on the surface of an unfathomably deep ocean. The universe has been doing this beautiful dance for 14 billion years, and it will continue for trillions more. We are a brief, sparkling moment in that eternal dance. To reach the end of this journey is not to arrive at a final, closed answer. In the magnificent, ever-expanding realm of science, every solved mystery merely opens the door to 100 new, more beautiful questions. We still do not fully understand the exact nature of dark energy. We still grapple with the staggering contradiction between the predicted energy of the vacuum and the gentle acceleration we actually observe in the cosmos. The ultimate theory that unites the microscopic dance of the quantum fields with the macroscopic curves of gravity remains hidden in the dark, waiting for a future generation of curious minds to bring it into the light. But this lack of absolute certainty should not bring us anxiety or fear. It should bring us a profound, comforting peace. The fact that the universe is still hiding secrets of such unimaginable magnitude means that reality is an endless adventure. The cosmos is not a finished book. It is a living, breathing story, and we are privileged to be a part of it. As we gently close this chapter of our exploration, I invite you to carry this new perspective with you into your everyday life. When you step outside into the quiet night and look up at the vast, scattered light of the stars, remember that the dark spaces between them are not empty. They are alive with the invisible, eternal hum of creation. When you sit in a quiet room, listening to the soft rhythm of your own breathing, remember that the empty air around you is boiling with microscopic, fleeting ghosts that hold the very fabric of existence together. You are never truly alone. You are wrapped in the gentle, infinite embrace of a universe that is constantly vibrating with pure potential. Our shared journey into the quantum vacuum has come to an end, but the grand voyage of discovery continues. The universe is vast, ancient, and infinitely beautiful, and there will always be more mysteries waiting in the dark. I hope this quiet exploration has brought you a sense of profound peace, a deeper understanding of our miraculous existence, and a renewed sense of wonder for the cosmos we call home. Keep looking up, keep asking questions, and never lose your reverence for the gentle, magnificent silence of the unknown. Thank you for walking beside me, Walter, the explorer, through the endless night. May your own journey through this beautiful universe be filled with continuous awe and abiding peace.